Okay, we are starting a new unit in our book. It's Unit 3, and in this unit we're going to be talking about equations, inequalities, and functions. This Chapter 7 will deal with equations and inequalities, and then Chapter 8 will deal with the functions pretty much. So Chapter 7, in Section 7-1, the first section we're going to be talking about solving equations with variables on each side. Now yesterday in class, or today in class, we actually did a little review on solving equations, but the variables in that case only were on one side of our equal sign. But now we're actually going to be solving equations with variables on both sides of the equal sign. You do it the same way as you do solving equations with them on one side, but we're going to go through the motions and just see how that works. So the first thing you're going to do is either use your addition or your subtraction property of equality. So here we have 2x plus 3 equals 3x. Well, we're going to combine our like terms. And what are our like terms? 2x and 3x, right? Okay. So we're going to move our 2x over to be with our 3x. That's the first thing we're going to do. And we'll subtract 2x from both sides because we subtract from this side of the equation. We have to subtract it from that side of the equation. So 2x minus 2x is 0. And the only thing we have left to bring on down on this side is 3. And 3x minus 2x is 1x. So what does x equal? X equals 3. So we've solved the equation. Now we should probably check our answer. Check your answer. How do you check your answer? Well, if x equals 3, we go back to our original equation, 2x plus 3 equals 3x, and we substitute in 3. So 2 times 3 plus 3 equals 3 times x, which is, we now know, 3. Is 2 times 3, 6, plus 3 equal to 3 times 3, which is 9? Yes, 9 equals 9. So x is, in fact, the correct answer. And that's how you check your equations. All right, let's try this. Oops, sorry. Here we go. Okay. Let's try a couple of others. We have solve 5x plus 4 equals 3x minus 2. I'm going to rewrite that. 5x plus 4 equals 3x minus 2. So we're going to solve this equation and then we'll check our solution. Remember, we've got to think about what our like terms are, and we have like terms 5x and 3x, and we have like terms 4 and negative 2. Okay? Remember that little review we did about like terms yesterday as well in class. Okay, so we got to combine our like terms. I'm going to move my 3x over to be with my 5x, so that's my first step. I'm going to minus 3x on both sides of my equal sign. I'm going to keep my equal sign lined up. Minus 3x is 0. What do I have left over here? Only my negative 2. And over here, I still have my 4, so it just comes down, right? And 5x minus 3x is 2x. Now I have 2x plus 4 equals negative 2. Now I'm going to combine my other like terms. I'm going to move my 4 to be over there with the negative 2 because they're like terms. Those two cancel out. I have 2x equals negative 2 plus a negative 4 is a negative 6. Divide both sides by 2. X equals negative 3. So again, just like what we were doing before with equations, with variables on one side in our equations, we're trying to isolate our x. We want to get our x alone. So x equals negative 3. And we can check our answer. And to check, I would take my original equation, 5x plus 4 equals 3x minus 2, and substitute in what I found x to be, which was negative 3, right? So 5 times negative 3 plus 4, does that equal 3 times negative 3, again, because it's 3x minus 2. 5 times negative 3 is negative 15 plus 4. Does that equal negative 9 minus 2? Negative 15 plus 4 is negative 11. Does that equal a negative 9 plus a negative 2, which is also also negative 11. So yes, my answer x equals negative 3 is correct. Okay, let's try the next problem. Here we're going to run in, I'm going to erase a little bit so it's not in our way. Equals. So next problem, solve 2.4 plus a equals 2.5a minus 4.5. Oh yes, look, they're decimals, but do not panic, they're just decimals. So I'm going to solve the equation the same way. We're going to get the like terms together. And we know that a and 2.5a are like terms, and we know that 2.4 and negative 4.5 are also like terms. So this time, let's move our 4.5 over to be with our 2.4. Okay? Those two will cancel out. Negative 4.5 plus 4.5 will leave 0. The only thing I have to bring down on this side of the question is 2.5a still left over. And I have a down over here. And 2.4 plus 4.5 is 9.9 plus a equals a from both sides, so that's not a minus a on both sides, right? Remember, there's a 1 in front of that. Remember? So a minus a will be 0, and I'll just have to put 9. Notice I'm keeping my equal signs lined up. 2.5 minus 1 is, is 1, excuse me, sorry, negative, is 1.5a. 1.5. Now what are we going to do? Divide by a decimal. Well, a calculator for that. So a equals, and I pull out my calculator, and I divide 1.5 into 6.9, and I get, calculator on, 6.9 divided by 1.5 is 4.6. So a equals 4. We can check our work by what? Taking this 4.6 and plugging it back into our original equation. 4.6 value here and the 4.6 value there, and if it should be a true statement. Okay. Well, let's see if it'll let me change the page here. Okay. All right. Video stores. A video store has two, so we can use equations with variables on both sides to solve everybody's favorite word problems. So, a video store has two membership plans. Under Plan A yearly membership costs $30 plus $1.50 for each time you rent a video. Under Plan B, the yearly membership cost is $12 plus $3 for each rental. What number of rentals results in the same yearly cost? Okay, so I've read the problem. Now I need to sort of analyze the problem. What do I need to know? There are two plans. There's a Plan A and there's a Plan B. So knowing that, I'm going to have probably two different thoughts I'm going to have to work with, Plan A and Plan B. And I'm going to compare those two plans. So Plan A, it costs, my highlighter going here, costs $30 plus $1.50 for each rental. How can I write that as an equation? The plan costs $30 plus $1.50 times each rental. Shall we call that R? All right. And Plan B, the membership costs $12 plus $3 for each rental. How do we write that as an equation? That would be $12 plus $3 times each time you rent the movie, or 3R. Okay? Now, what number, the question question is, what number of rentals, that's key, what is it asking you? What number of rentals result in the same yearly cost? That means, how many movies would I have to rent to get the same cost out of each plan? In other words, what are these two equations equal to each other? So this is exactly how we would write this equation. 30 plus $1.50 times R equals 12 plus 3R. I'll put my like terms together. I'm going to put my R's together. And I find out that those two cancel out. I get 30 equals 12. And we subtract 3 from $1.50, and we get $1.50. Now I'm going to subtract 12 from both sides. And I get 30 minus 12 is 18 equals $1.50. I have $1.50. Now I'm going to go to both sides. I'm going to find out the value. How many of those do I have to rent to have these two be equal equations? And if I take 18 on my calculator and divide it by $1.50, oh, turn on 18 divided by $1.50, I would have to rent 12 movies. And then Plan A would, if I went 12 movies under Plan A, it would equal the same cost as under Plan B. That would be your sentence. 12 movies is the number of rentals that would result in the same yearly cost. Don't forget about writing sentences for your answers or sentence. Okay. All right. Here are your practice problems for today. You have 6 problems. Solve each equation. Check your solution. Take your time. Do this neatly on graph paper. So show all your steps. Do not skip writing down any of the steps that you have to do. The neater you and slower you do the work, the fewer careless errors you will have. Okay, good luck with it. And we'll check these tomorrow, next day in class. And we'll do practice problems when you get to class again. All right, thank you guys.